Hi, please support me through PayPal to devinwitham@gmail.com. devinwitham@gmail.com is all lowercase, it's one word. I also do tutoring both online and in person. If you're interested in tutoring, you can reach me at that email. I'm based in Fairfax, Virginia. Please support my channel. Please subscribe to my channel. I've started on this YouTube channel of mine recently, and I've really been enjoying it. Doing proofs, doing math problems. Understanding is more important than memorizing in mathematics, I think. I'd like to hear from you in the comments about what you think. Part of me thinks that we should teach math slower. We should learn math more slowly and basically go through all the proofs, proving everything to ourselves so that we understand everything in math and physics. What do you think? Do you think this would take too much time? Do you think it would slow us down? I think it might actually speed us up in terms of creativity. For just one example, so in coming up with proofs of the double angle of the sum formulas for sine and cosine, I got really good exercise in rotating in the two-dimensional Cartesian plane about the origin. I got really good at that. So it was I think it's a shortcut. Like, it gives me, and I really have this mental thing down about what a rotation is, how to rotate things. And for instance, that thing about rotation helped me prove the equivalence of the two definitions of the dot product. I mean, you might say, well, you're just using your skills gained from one proof to prove something else. I mean, what's this good of proving things? Shouldn't you just use the results for engineering? Well, I really think it's important to prove everything to yourself, to read a proof or to do a proof of every single fact you learn in math, like the Pythagorean theorem, because that's the beauty of math, and it gives you the sort of tools to go and do other things. Like my proof of the Pythagorean theorem involved similar triangles, and similar triangles are used everywhere to prove things, and it gives you a feeling of satisfaction, like you own math or physics, that you know where everything comes from. And it helps you because you know if you change the axioms, you know what other theorems are going to change. So let me talk about some theorems. So some things I'm thinking about right now how to prove or some YouTube videos I'd like to do. One thing I'd like to do is a YouTube video on how high you can jump on various planets, including moons like Europa or our moon, or asteroids like there's this asteroid called Oumuamua or something that might be alien. So I'm thinking about how to do that, those calculations, how high you could jump. Another YouTube video I'm thinking of doing is proving the equivalence of the definitions of the dot product. For me, that's going to be harder than proving the equivalence of the definitions of the cross product. For me, that's going to be harder than the dot product one I did, because, as you know, the cross product is a vector, whereas the dot product is just a scalar. So there's that complication. Last night I was working on a video on deriving the equation of an ellipse, but I've done that several times on paper, but never a YouTube video. I was having trouble deriving the equation of an ellipse. So I frequently do. It's really complicated. But I think, you should all go through these things of deriving things. Like, that's one example. Your teacher might tell you that the equation of ellipse is x squared over a squared plus y squared over b squared equals 1, but don't believe your teacher. Don't take her word for it or his word for it. Derive it yourself, prove it to you for yourself, or read a proof, or look at a proof on YouTube. But every single fact in math and physics you should prove to yourself or see a proof of it. Same goes for the equation of an ellipse. Why are ellipses and hyperbolas so important? Because planets go around the sun in ellipses. That's how we were able to send Perseverance to Mars. We knew about ellipses. We knew that the planets go around the sun in ellipses. So we were able to calculate the elliptical orbit of the spacecraft. So ellipses is very important for space travel, and I'd like you to understand ellipses. That means do not accept that x squared over a squared plus y squared over v squared equals 1 is an ellipse. By no means accept that. Convince yourself that that's an ellipse. Start with the definition of an ellipse. The one I'm starting with is basically it's the locus of all points, such that the sum of the distances from that point to two points called foci is constant. Then there's a hyperbola. But difference, I don't know how the Greeks did it. The Greeks did it with convex sections. I don't know how they did it. It's just much easier for me to do it with these locus definitions of sum and difference of points and using the distance formula. The Greeks were just amazing. Slicing a cone. Alright, I think I'm going to stop this video here. I'm sort of running out of things to say.